Oh, welcome again to another exciting time of learning with Mr. Jeremiah Ajali. I hope you're reading your books at home. Please study. Always study to show yourself approved, so that you will not be ashamed. So study your books, study your books, study your books, study your books, study your books. Don't be afraid of it. Study, study, study. Study in the daytime, study in the nighttime, study everywhere. Study in the car, study in the parlor, study in the room, study your dreams, study everywhere. Get married to your books right now because it's the only way to get 300 and above as we are targeting in our Jamb exam. Hope you are alive and bubbling, because I'm so bubbling right now to be with you. After the last video indices, I've been bubbling to do this next one, which is logarithm, and it's going to be a short time. I tell you the truth, we are going to enjoy ourselves here. Okay, before we start, can you say this after me? As I study today, I commit my ways to the Lord. My plans are established. I am blessed. My memory is blessed. Say it again. My memory is blessed. Jesus Christ is Lord and Savior in my life. I receive wisdom and understanding from Him. Amen. Okay, today we'll be looking at logarithm. And the first thing we'll look under logarithm are the 8 laws of logarithm. Hope you have your writing materials, your pen. Get your pen, get your book, use your pause button to pause me. At times I get to be running so fast when I'm in the elements, my right elements, environment in mathematics, I just get in the mode and I'm just going. Please pause me, pause the button, pause the video and replay, follow me, solve along, don't get left out, don't be a spectator, participate, so you can get full grasp of whatever we're doing here. Okay, let's go down to the main deal. 8 laws of logarithm. Number 1, log m to base a plus log n to base a. Same base, you take 1. Since this is plus, you multiply m times n. Okay, e.g. log 8 to base 2 plus log 3 to base 2. Now this is going to give us take 1 base, which is to base 2, since they're the same. Take 1. 8 times 3 is what? 24. Okay. Number 2, log m to base a minus log n to base a. Now in this case is minus, so you take 1 base, this is the same, and since this is minus, you divide. When it is plus, you multiply. When it is minus, you divide. Okay, e.g. log 8 to base 2 minus log 4 to base 2 is going to give us log, take 1 base, base 2, 8 divided by 4, and of course 8 divided by 4 is 2, so this is log 2 to base 2. Log 2 to base 2 is 1. Of course you know that. We'll soon get that as a rule. Number 3, log a to base a is 1. Log a to base a is 1. Okay, e.g. log 2 to base 2 is 1. Log 10 to base 10 is 1. Okay. Number 4, log 1 to any base is 0. Log 1 to any base is 0. Okay, to any base, to any base. So if you have log 1 to say base 2, it will be 0, as well as log 1 to base 3 will be 0. Log 1 to base 4 will be 0. Log 1 to base 10 will be 0. Log 1 to any base is 0. Okay. Number 5, log to base a n raised to power p. Now this is having a raised to power. Okay, so have log n raised to power p to base a. Now this part comes down here to give us p log n to base a. Okay, and that gives us that. Now take for instance, we have log 8 to base 2, log 8 to base 2. Now log 8 to base 2, 8 is 2 raised to power 3, right? Okay, so this 3 can come down here since this is power that you have 3 log 2 to base 2. Log 2 to base 2 is 1, so 3 times 1 is 3. Okay, that's the fifth law. Hope you're understanding. I wish we can be together so you ask questions alongside, but nevertheless you have me on various platforms, so you should be able to get across to me if you have any question. Okay, law, that should be law 7. Law 7. Why, it's windy here. Law 7, we call it change of base. If you have log a to base b, log a to base b, and you want to change the base, we call this change of base. You want to change the base, you can change it basically to any base. You can change to any base. Assuming you want to change to base x, so this will be log to base x. You want to change to base x from base b, so you take log to base x, take this first a, divided by log to base x of b. Okay, take for instance, if you are told to simplify this, log 8 to base 3 is going to be, we can change to base 10, log 8 to base 10 divided by log 3 to base 10. So this, okay, you can easily get that from your 4-figure table, log 8 to base 10. Hope you know in your 4-figure table it's in base 10. Okay, number 8 is if you have a raised to power log n to base a. Now the log is raised to power here. Now whenever I have a scenario of this sort, such that the log is raised to power and this base here is same as this base here, the base of the logarithm is same as this base here, the answer is simply n. Okay, e.g. 2 raised to power log to base 2 of 5, the answer is simply 5. So it's this base and this base 2, the answer is 5. The another way this law is expressed is e raised to power lim s. Okay, where lim s is the natural logarithm of s. Lim s in mathematics is the same thing as log to base e of s. Okay, lim s is log to base e is the same thing in mathematics, where e is the Euler constant. Now if you look critically, this base here is same as this base here, so the answer is s. So the simple law says e raised to power lim s is equal to s. Okay, as simple as that. Now we'll solve questions now. I hope to cover over 25 questions before the end of this exercise. Okay, first question says evaluate log 4 to base 1 over 2. Evaluate log 4 to base 1 over 2. Now this is the same as log 4 is 2 raised to power 2 and 1 over 2 is 2 raised to power minus 1. Okay, is here is same as what is here. Okay, did I cover this law? I don't think I covered this law. Okay, I think I skipped this law. The law simply says if you have log a raised to power b and this is s raised to power y, that is going to give you, take the raised to powers, which is this b over y log, then you take this a s. So if I have log 8 to base 4, is going to give me log 8 is what, 2 raised to power 3 and 4 is 2 raised to power 2. Okay, now you take the raised to powers, that gives you 3 over 2 log 2 to base 2. This is 1. Okay, 3 over 2 times 1 gives you 3 over 2. So if you have the base raised to power, this raised to power, you take the raised to powers and that. Okay, the same thing I want to apply here. 4 is 2 raised to power 2. 1 over 2 is 2 raised to power minus 1. Okay, 1 over 2 is 2 raised to power minus 1. So we take the raised to powers, which should be 2 over minus 1 log. We now take what is left, 2 to base 2. Now this is 1, and this is minus 2 times 1, and that is minus 2. Okay, very simple. We'll be using this law often. I think I skipped it in one of the numbers there. But nevertheless, this is it. This is the law, and you need to take note of that. Okay, so that's the first question. The second question is demanding that we solve for s. We're told to solve for s if log s to base 81 is equal to 1 over 2. Log s to base 81 is equal to 1 over 2. Now, introduce 81 here, so you have log 81 to base 81, and you have removed the logarithm. So this is going to give me log 81 to base 81 raised to power s. Okay, I just introduced 81 here. Since you introduce 81 here, you also have to introduce it here to make it consistent. So it will be 81 raised to power 1 over 2. Okay, I just introduced 81 here and 81 here to make it the same, consistent. It's now consistent in mathematics. What you do to the left hand side, you should also do to the right hand side, and you have not changed the mass. So s can come down to give us s log 81 to base 81 is equal to, this means the square root of 81 from indices. Log 81 to base 81 is 1. S times 1 is s, is equal to root of 81 is 9. So s is equal to 9. This is number 2. Number 3, we're told to simplify log 49 raised to power a to base 7 minus log 0.01 to base 10. Okay, now if you look critically, 49 has 7 raised to power 2, and this has a 10 there. So this is 7 raised to power 2a to base 7 minus log, this is 1 over 100. Okay, and 1 over 100 from indices is 100 raised to power minus 1, and 100 is 10 raised to power 2 times minus 1 gives you minus 2. So this is the same thing as 10 raised to power minus 2. Okay, so I can write it to be 7 raised to power 2a to base 7 minus log 1 over 100 is 10 raised to power minus 2 to base 10. Okay, so this can come down to give us 2 log 7 to base 7 minus 2 log 10 to base 10. This is 1, this is 1. So it gives us 2 minus 2, which is 2 plus 2. And sorry, this is 2a. So bring 2a here, 2a to be 2a plus 2, and that is, bring 2 out, you have a plus 1. Okay, there is an a here, so the a is supposed to come down with the 2a. So 2a minus this is 2a, minus plus, bring out that. Okay, so that is number 3. Number 4 is demanding that we simplify. It says simplify log 16 divided by log 2. Okay, log 16 divided by log 2. Now we can make this the same as the base. We can make this log 2 because 16 is 2 raised to power 4. Just so as a reminder, if there is no base, it means it's in base 10. When a logarithm doesn't have a base, it is in base 10, so it is a norm. Okay, so this is log 16 is what, 2 raised to power 4 divided by log 2. Okay, 4 comes down to give us 4 log 2 divided by log 2. Log 2 cancels log 2 to give us 4 times 1, and that is 4. The next, we are told to simplify log 10 to base 8 divided by log 8 to base 10 divided by log 4 to base 10. Okay, now this is something as log 8 is 2 raised to power 3 to base 10 divided by log 4 is what? 2 raised to power 2 to base 10. So this 3 comes down to give us 3 log 2 to base 10 divided by 2 log 2 to base 10. Log 2 to base 10 cancels log 2 to base 10, and that is 3 over 2 left. Okay, the next is we are told to simplify log 4 to base 2 plus log 2 to base 4 minus log 5 to base 25. Okay, now if you look critically, there is a 2 here, there is a 2 here too, and there is a 5 here. So this is going to be log 4 is 2 raised to power 2 and 2 is there, so 2 raised to power 1, same thing, plus log 2 is 2 raised to power 1 and 4 is 2 raised to power 2 minus log 5 is 5 raised to power 1, 25 is 5 raised to power 2. So take the powers, 2 over 1 log 2 plus take the powers 1 over 2 log 2 minus take the powers 1 over 2 log 5. This is 1, this is 1, this is 1. So that is 2 plus 1 over 2 minus 1 over 2. Okay, and that is 2. Okay, it's becoming much more interesting now. The next question is asking that we simplify 3 log 9 to be 6 plus log 12 to base 6 plus log 64 to base 6 minus log 72 to base 6. Okay, looking carefully, you see that they are all in base 6. So this is log 9 raised to power 3, taking this to base 6 plus log 12 to base 6 plus log 64 to base 6 minus log 72 to base 6, plus you times minus you divide. So if I take one base, log to base 6 to be 9 raised to power 3 times 12 times 64 divided by 72. Okay, looking critically, 12 here is 1, 12 here is 6. So have 9 raised to power 3 times 64 over 6. Let's simplify this by the side. Okay, 2 here is 3, and 2 here is 32. So it's 9 raised to power 3 times 32 over 3. Okay, now 9 is 2 raised to power 2, right? 3 raised to power 2 rather. 9 is 3 raised to power 2. So we can write this to be 3 raised to power 2, which is 9 raised to power 3 times 32 over 3. Okay, 9 is 3 raised to power 2. So indices, multiply the powers, 3 raised to power 6 times 32 over 3. Now, you know, canceling, this 3 has to cancel one of these 3's here. So if we cancel, we'll be left with 3 raised to power 5 times 32. Now, if you still remember indices correctly, 3 raised to power 5 times 32 is what? 2 raised to power 5. Okay, power, same powers, we can multiply this to be 6 raised to power 5. Okay, so this is 6 raised to power 5. So that's log. This guy is 6 raised to power 5 to be 6. 5 comes down to give you 5 log 6 to be 6. This is 1. 5 times 1 is 5. Okay, interesting, right? Okay, the next question is demanding we simplify. It says simplify 2 log 2 over 5 minus log 72 over 125 plus log 9. Don't forget, most of these questions are Jamb questions, okay? Past Jamb questions. So this is now no base, so it means it's in what? Is in base 10. So this means it's log 2 over 5 raised to power 2 minus log 72 over 125 plus log 9, and this is 4 over 25, so that's log 4 over 25 minus log 72 over 125 plus log 9. Okay, now minus, you divide, so this is same thing as log, since they're all in base 10. This is 4 over 5 25 divided by 72 over 125 times 9. Okay, let's simplify this by the side. That will be 4 over 25. Okay, changing divide to times, this guy will have to flip to be 125 over 72 times 9. Okay, 25 here 1, 25 here is going to give us 5. Okay, then 9 here is 1, 9 here is 8, 9 here is 8. Okay, 9 is 8. Then 4 here is 1, 4 here is 2, so I left with log, this 5 over 2, 5 over 2 to base 10. Okay, now they didn't leave the answer this way, so we have to simplify further. This is something as log 5 to base 10 minus log 2 to base 10. Okay, now look critically, 5 is 10 raised to power 10 over 2, so this is log 10 over 2 to base 10 minus log 2 to base 10. Okay, so we'll break this down again to be log 10 to base 10, divide is minus log 2 to base 10 minus log 2 to base 10. Log 10 is 1. This is same as this, is like minus p is minus 2p. Okay, and this was how the answer was left. Okay, the next question is demanding that given that log s to base 2 plus log y to base 2 is equal to 8. The question is saying we should find log 8x to base 2 plus log 4y to base 2. Okay, now this is where I want you to think a little. What do you think you can do here? You were given this and you were asked to get this. Now if you look at what you are asked to get critically, you see some parts of what you were given: log s to base 2, log y to base 2, y to base 2, just this 8 and this 4. So you can split that. Since you are told to find this is same as log s to base 2 plus log 8 to base 2 plus log s to base 2 plus that was why it was multiplied to give you 8s, then plus log 4 to base 2 plus log y to base 2. Okay, so this is same thing as 8 is 2 raised to power 3 to base 2 plus log s to base 2 plus log 4 is what? 2 raised to power 2 to base 2 plus log y to base 2. Now this will come down to give you 3 log 2 to base 2 plus log s to base 2 plus log, this will also come down here to give you 2 log 2 to base 2 plus log y to base 2. Log 2 is 1, log 2 is 1, that's 3 plus 2 plus log s to base 2 plus log y to base 2. Okay, now you see log s to base 2 log y to base 2, which is the same thing here. I have said that from what was given to us, that when you add them, it's going to give you 8. So it means this addition is 8. So that is 3 plus 2 plus 8, and that is 13. Okay. The next question is demanding that we solve and simplify this logarithm log 62.5 to base 5 minus log 1 over 2 to base 5. Okay, now this is something as log 62.5 is 625 over 10 to base 5. Okay, this removing the points here, and this is something as minus log 1 over 2 is something as 5 over 10. Okay, I'm bringing everything to have 5 and 10s because I can easily work with that since I have it in base 5 here. Okay, so looking critically, this is same thing as log 625 to base 5. Now this is divide, so it means it's minus log 10 to base 5 minus, this minus is for everything here, so log 5 to base 5. Now this divide means what? Minus log 10 to base 5, breaking it down. Okay, now this is log 625 is 5 raised to power 4. 625 is 5 raised to power 4 minus log 10 to base 5. Okay, this minus goes in to give you minus log 5, which should be 1. Minus goes in here to give you plus. Be careful, this minus is for everything. Okay, so this is going to give you plus log 10 to base 5. Now, minus 10 to base 5 plus 10 to base 5 cancels off, and we're left with these two guys. Bringing this forward, I have 4 log 5 to base 5 minus log 5 to base 5. Log 5 is 1, log 5 is 1. So that's 4 minus 1, and that is 3. Okay. Whew. Next question is demanding we also evaluate. Each video will last for an hour, don't forget, so enjoy yourself. Evaluate, think this about the 10th question. Log to base 5, 0.04 divided by log 18 to base 3 minus log 2 to base 3. Okay, now 0.04 is same thing as what? 4 over 100. Okay, to base 5 over log, same base, take 1 minus what do you do? Divide. 18 divided by 2 is 9. So this is log 4 divided by 100 is 1 over 25 to base 5 over log 9 is what? 3 raised to power 2 to base 3. This 2 comes down to give us log 1 over 25 is 25 raised to power minus 1, which is 5 raised to power 2 times this gives you minus 2. So this is same thing as 5 raised to power minus 2. 5 raised to power minus 2 to base 5 over log 3. This 2 comes down to give you 2 here. So this guy comes here to give you minus 2 log 5 to base 5 divided by 2 log 3 to base 3. This is 1, this is 1. Because log 5, log 3, they are both 1. So minus 2 divided by 2, that's minus 1. Okay. The next question, we're asked to also simplify. We're asked to also simplify 16 raised to power 3 over 2 plus log 0.0001. Be careful when you write zeros this way, lest you skip 1. Okay, plus log 32 to base 2. Now indices. Okay, so this is square root of 16 raised to power 3 plus log 10. This is 1 over 1 0 0 0 0 to be 4 zeros, okay, because you have 4 numbers here, 1 2 3 4 after the point, plus log 32 is what? 2 raised to power 5 to base 2. Okay, so square root of 16 is 4 raised to power 3. 4 raised to power 3 is 64, plus log 1 over 10,000 is something as 10,000 raised to power minus 1. 10,000 is what? 10 raised to power 4. This minus makes it minus 4. Okay, so this is something as 10 raised to power minus 4 to base 10, plus 5 log 2 to base 2. Log 2 to base 2 is 1, so that gives us 64. This comes down to give us minus 4 log 10 to base 10, which is 1, plus 5. Okay, this is 64 minus 4 plus 5. Okay, and that gives us 65. Okay, that's how we roll. Okay, the next question is demanding that we simplify log 96 to base 2 minus 2 log 6 to base 2. Okay, looking critically, you can break this down to have this is 32 times 3, and this is 2 times 3, so we can break that down. Or simply we could divide 90, because this is 36 into that. Okay, let's proceed. This is going to give us log to base 2. 96 is what? 32 times 3 minus 2 log 6 is what? 3 times 2 to base 2. I'm trying to get 2's. That's what I'm trying to do, because I see base 2 here. So I'm trying to get 2's, and I see 2 here because the 2 is 2 raised to power 5, and I see 2 here already. So this is log 2 to base 2, log 32 to base 2, times means that it was formerly plus here. Okay, minus 2 into minus 2, this bracket has minus 2 in front. Don't forget that's log 3 to base 2, times means plus. Okay, 2 to base 2. Okay, yes. Now looking critically, this is log 32 is what? 2 raised to power 5 to base 2, plus log 3 to base 2 minus 2 into log 3 to base 2, plus this is 1. Okay, this comes down to give us 5. Log 2 is 1. Okay, I'll be boycotting some steps now, because you should be seeing by now that log 2 is 1. So this comes down to give you 5 log 3 to base 2 minus this 2 goes in to give you 2 log 3 to base 2, and this goes in to give you minus 2. We can deal with this 2 as much as we can deal with this 2. 5 minus 2 gives us 3. Then this is like 1p minus 2p. 1p minus 2p will give you minus 1p. Okay, the p in this case is log 3 to base 2. Okay, that's the answer. Okay, now the next question is saying that we're giving log 2 to base 10 to be 0.3010, and log 3 to base 10 is 0.4771, and we're now told to evaluate log 4.5 to base 10. Okay, we're told to evaluate log 4.5 to base 10. Now log 4.5 is the same thing as what? Log 45 over 10 to base 10. Okay, and this is what? Log 45. Divide is minus. Okay, don't forget that all in base 10s. Okay, then log 45 is what? 9 times 5. Okay, or 9 times 5 will give you, will now start giving you 5, which you don't want. You want 2 and 3. So you can simply say that 45 is um, oh um 45, yes, we have 9 and 5, but could we have cancelled here? I'm just saying we could have cancelled here even, and we'll be getting, it will be simpler cancelling here. Okay, so we're supposed to cancel here too, because I'm trying to get log 2 and log 3. So 45 over 10, look critically, it's 5 here is 2, 5 here is 9, and if you have 2 and 9, you already have 2 and 3. Okay, so the idea is to get log 2 and log 3 in this expression. That's the whole idea. So this is going to be the same thing as log to base 10 of 9 over 2, which is log 9 to base 10 minus log 2 to base 10. Okay, and this is same thing as log 9 is what? 3 raised to power 2 to base 10 minus log 2 to base 10, which is equal to 2 log 3 to base 10 minus log 2 to base 10. Okay, um log 3 to base 10 was given to us here, which is 0.4771 minus log 2 to base 10 is what? 0.3010. Okay, so if you multiply this should get 0.9542 minus 0.3010, and subtracting is going to give you 0.6532. Okay, the next question is demanding that we solve. We're given, wow, this is good, we're given log 4.4 to base e to be equal to 1.4816 and log 7.7 to base e to be equal to 2.0142. I am now told to evaluate log 7 over 4 to base e. Okay, we're told to evaluate this, and we're given these two. Now from this, the trick is simply just like the question we solved before now, is to bring out from this, you should get log 4.4 to base e, and you should get something like this here, so you can substitute. Okay, now 7 over 4, watch this, 7 over 4 is the same thing as 7 over 4. If I multiply it by 1.1 and I multiply it by 1.1, did I change anything? No, because this can simply strike off and it still remains 7 over 4. It's consistent in mathematics. So if you multiply this, you have 7.7 over 4.4. So 7 over 4 is the same thing as 7.7 over 4.4. That is what they want you to see. You know, if you press this with your calculator and you press your calculator, it's going to give you the same thing. Okay, so we can simply rewrite this to be 7.7 over 4.4 to base e. So it's easier now. That's log 7.7 to base e divided is minus 4.4 to base e. Okay, now what's this? This is what? 1.4816 minus, what's this? Oh sorry, this is for this, which is 2.0142 minus log 4.4 is for this, 1.4816. Okay, subtracting these values, you'll be getting 0.5326. okay, that's what you'll be getting. Okay, next question is demanding, we're given log log 7 to base 10 is equal to x, and log 2 to base 10 is equal to y, and we're told to evaluate log 35 to base 10. Okay, now 35 is what? 70 divided by 2. I think you have seen that already, to base 10, and that's log 70 minus log 2, all to base 10. Of course, 70 is 7 times 10, so that gives you log 7 plus log 10, which is times, all to base 10, minus log 2 to base 10. This is x, log 10 10 is 1, and this is y. Okay, okay, okay. So that is x minus y plus 1. Okay. The next question is saying that log y to base 10 is 2, and log 2s to base 10 is 1. We're told to evaluate log root y to base 10 divided by 3x. Okay, we're told to evaluate that 3x. So it means we need to get x, so we can substitute it here, and also we need to get this. Now look at this critically. This is something as log. Look, this is sweet. Y raised to power 1 over 2 to base 10 divided by 3x. Okay, this can come down to give you 1 over 2 log y to base 10 over 3s. Now y to base 10 is 2, so we can put 2 there to be 1 over 2 times 2 over 3s. Okay, so this is 1 over 3s, because this time this gives you 1. So the next thing we have to now do is to substitute s here. So we need to get what s is here. We have seen that log 2s to base 10 is 1. Okay, now how can you get 1? How can you get 1 in logarithm? Do you remember? Log 10 to base 10 is 1. So this is same as this. Now this log takes care of this, and 2s is equal to 10. By comparison, this is equal to this, so s is 5. So if s is 5, 1 over 3s is going to be 1 over 3 times 5, and that is 1 over 15. Okay, so the answer is simply 1 over 15. Hope that wasn't stressful. I want to start going into solving logarithmic equations. So let me get the questions. Logarithmic equations from this. Now solve the first question is asking us to solve log s minus log 2 is equal to log 3. We have to solve for s. Now this is a logarithm equation. Okay, so this is log, that in base 10, don't forget, s over 2 is equal to log 3. Now this is in base 10, this is in base 10, meaning that by comparison, x over 2 is equal to 3, and that s is equal to 6. Okay, well, also to solve for s, if s into log 243 is 243 to base 3 minus log 9 to base 3 is equal to log 27 to base 3. Okay, now this is something as log s into log to base 3 minus your divide, right? 243 over 9 is equal to log 27. Okay, now looking critically, 3 here is 3 into 24 is 8, and this here is 1, so that is 81 over 3 to base 3 is equal to this. Okay, 3 here 1, 3 here 27, so that's x log 27 to the base 3 is equal to this. Now by comparison, log 27 to base 3, log 27 to base 3, and there's something in front here. It means whatever is in front here, it's whatever is in front here. and what is here is 1, so it means s is equal to 1. Okay. The next question we want to solve, initial question we want to solve, is log s to base 3 is equal to 3 plus log 0.5 to base 3. Okay, so this is log s to base 3 is equal to 3 plus 0.5 is what? 5 over 10 to base 3. 5 over 10, 5 over 10 is same thing as what? 1 over 2. Okay, 1 over 2 is equal to 3 plus log 1 over 2 to base 3. Okay, now we can simply bring our logarithm here, because if I introduce log 3 here, I didn't change anything, it's still 1. So 3 log 3 is 1, meaning that this becomes taking this 3 up, you have log 3 raised to power 3 to base 3, the same as this, bringing this down, the same as this, plus log 1 over 2 to base that. Okay, now this is 27, so that gives me log 27 to base 3 plus log 1 over 2 to base 3. Now when you have plus, what do you do? You times, so that's log 27 over 2 to base 3, meaning that log s to base 3 is equal to log 27 over 2 to base 3. This cancels this, s is equal to 27 over 2. Okay, log there is a question I need to solve. Let me see if I can get it. There's a question I need to solve for you, a very interesting question. I should have it here. 1 minute please. It says yes, I see it. It says um it says 5 raised to power minus 3 log 2 to base 5 times 2 raised to power 2 log 2 to base 3. I should have evaluate this. It says we should have evaluate this. Okay, now this is e raised to power lim s, which I told you about. So if what is here is what is here, the answer, you get this. If what is here was there, you should pick that. So this is 5 raised to power log 2 raised to power minus 3 to base 5 times 2 log to base 2. This is 3 raised to power 2. Okay, what is here is what is here, so this is the answer. What is here is what is here, so this is the answer. That's 2 raised to power minus 3 times 3 raised to power 2. This is 1 over 2 raised to power 3 times 9, and that is 9 over 8. Okay, and that is 9 over 8. Can we simplify this? Let's look at this. To evaluate log 32 to base 8 is equal to x plus 2. We're told to get x. Log 32 to base 8 is equal to x plus 2. We're told to get x. Okay, now this is the same thing as log. Let's remove log from here. 32 is what? 2 raised to power 5. 8 is what? 2 raised to power 3 is equal to x plus 2. Power, take it down. 5 over 3 log 2, which is 1, is equal to x plus 2. This is 1, so that gives you 5 over 3 is equal to x plus 2. Cross multiply. 3x plus 6, take this over, it goes to minus 1 is equal to 3x, so x is minus 1 over 3. Okay, we are told to also solve for s if 6 log 2 to base s minus 3 log 3 to base s is equal to 3 log 0.22 base 5. Okay, this is in base s and this is in base 5. Now this is log 2 raised to power 6 to base s minus log 3 raised to power 3 to base s is equal to 3 log what is 0.22 over 10 to base. Okay, so this is log this is what 64 to base s minus log 3 times 3 and 9 times 3 27 to base s is equal to log to base 5 of this is 2 over 10 raised to power 3. Now what's this? This is log to base s of 64 over 27 is equal to log to base 5 of this is 1 over 5 raised to power 3. Okay, now this is going to give us we need to compare. We need to, whatsoever is here, we should also have it here. We need to compare so we get it. We need to compare to get it. Okay, so this is 64 over 27 is equal to log 5 is 5 raised by minus 1 raised to power 3 to base 5, and that is minus 3. This is minus 3, so log 64 over 27 to base s equal to 1 over 3. Okay, to get s, if I introduce s here, so I have log ss, it will be 1. Okay, so I have to also introduce log there, so it will be log ss raised to power this, which should be 64 over 27 is equal to s raised to power minus 3. This is 1. Okay, so 64 over 27 is equal to s raised to power minus 3. Okay, this is 4 times 4 16. Yeah, this 4 raised to power 3 over, and this 3 raised to power 3 is equal to s raised to power minus 3. Okay, now look, see what I want to do here. This is something as 4 over 3 raised to power 3 is equal to s raised to power minus 3. Now for us to have minus here, we have to flip this to be 3 over 4 raised to power minus 1, which is now this. Okay, s raised to power minus 3. Now by comparison, this is minus 3, this is minus 3, meaning that s is this, so s is 3 over 4. Okay, wow, that was also a Jamb question. There are more questions I want to take, but I'm looking at my time right now. Let's see. Evaluate log 4 to this base plus log 16 to base 1 over 2. Okay, minus log 32 to base 4. Okay, now this is what 4 is 2 raised to power 2. This is 2 raised to power 1 over 2. Okay, plus log 16 is what 2 raised to power 4. Half is 2 raised to power minus 1 minus log, this is 2 raised to power 5, and 4 is 2 raised to power 2. So we take the powers, this over this, 2 divided by 1 over 2 log 2 to base 2 plus this over this, 4 over minus 1 log 2 to base 2 minus 5 over 2 log 2 to base 2, 1 1 1. So that is 4, okay, minus 4, okay, minus 5 over 2, and that is minus 5 over 2, which is minus 2.5. Okay, let's see if we can solve one or two more questions before we round off. I'm looking at my time. We are told to solve for x if log x squared to base 3 is equal to 2 log 0.5 to base 3. Okay, this is something as log x squared to base 3 is equal to 2 log, this is 5 over 10, which is 1 over 2 to base 3. Log x squared to base 3 is equal to 2 log 1 over 2 to base 3. Log x squared to base 3 is equal to log 1 over 2 raised to power 2 to base 3. Log x squared to base 3 is equal to log 1 over 2 squared is 1 over 4 raised to that. By comparison, this should be this. X squared is equal to 1 over 4, meaning that x is square root of 1 over 4, meaning that x is 1 over 2. Okay, we're also told to solve for x if log 25 minus log x is equal to 2 log 5, all in base base 10. So this is log 25 over x is equal to log